Today we're going to be looking at displaying data in Java Server Faces. As part of that, we're also going to look at guiding user choice. We'll split this into two parts. First, how to display static tables and how to guide user choice. And then we'll look at how to display dynamic tables. So there are two ways of displaying tables in JSF. We can use a panel grid, which will give us a fixed number of rows and a fixed number of columns. And we can use the data table element as well, which will allow us to display all the objects in a given collection. We'll specify the number of columns, but the number of rows will be determined by the number of objects in the collection. Both these elements are in the HTML library in JSF. So the panel grid will make use of two elements. First of all, the panel grid itself, which will, when it gets converted into HTML, render as a table element. Within that panel grid element, we will nest other elements. So it might be, for example, an output text. And each element that we put inside that table will occupy one column in a given row. If we want to put more than one element within a column in the row, we'll use a panel group element. Panel group will allow us to put in multiple elements, all grouped together as one element or one column within a row of that panel grid. And the panel group will render in HTML as a span element. So here we have an example of the panel grid. There are, in fact, quite a few attributes that we could specify, and I'm only showing a few here. First of all, the number of columns. This will tell the JSF environment how many columns to put into the table. The next two attributes are for us to specify the CSS style that we want for the header and for the columns. Now you can see for the header, which will be the header row in the table, that we're specifying a CSS style name. If we want to see the definition of that, of course, we would then go to the CSS file in this application. You will have noticed that column classes has got two CSS style names listed. And so what will happen is that the first style will be used for the first column, the second style for the second column, and then it goes back to the first style for the third column, and so on. This other attribute, rendered, is actually quite an interesting one. The default value for that is true, which means that this element, this panel grid, will be rendered by default. In other words, the user will see it on screen. But if we set that to false, then the panel grid will not be displayed. The useful thing about that is that we can replace the literal true or false with an expression language method call. And if that method then returns true, the panel grid will be rendered, and if it returns false, it won't be. Within the panel grid, we can specify a number of elements. So the first output text element will be displayed in the first column. The second output text element will go into the second column. And those together, because columns equals 2, those two will represent the first row. When we get to the third element, then that will be in the first column of the next row. And so row by row, these table cells are filled using the elements that are in the panel grid. Now, as I mentioned earlier, each one of those elements will occupy a single table cell. If we want to put more than one element into a table cell, we would need to make use of a panel group. And as you can see here, the panel group has now got within it two elements, a label and a value. Because they're in a group, they will only occupy one table cell in the rendered HTML table. And if I didn't specify columns equals 1 and just left it at columns equal 2 as on the previous screen, then this first group would go into the first table cell and the second group would go into the second column, which would be therefore only one row in the table. By changing the number of columns to 1, I'm now ensuring that this represents the first column and therefore the first row, and this is the second column and the second row. So it's easy enough to display information. But when we want users to enter information, if we just provide them with a text box, then they can enter almost any value they want, which is not always very helpful from the point of view of validation. And so it can be very useful, not only from our point of view as the developer, but also from the point of view of the user, to guide the user's choice, provide a fixed set of values from which to choose. And there's all kinds of ways that we can do that. In XHTML, we've got these 7 elements, and they pretty well do what the element name says they do. So this first one, for example, will provide a list box that will allow the user to select one value from that list. The next one will provide a list box from which the user can select many values, and so on. So we can display lists, we can display combo boxes, we can display check boxes. And in each of those 3 types, we can determine whether the user will pick one or many values. The exception to this, of course, is the radio button set, because the nature of a radio button set is that you are only allowed to choose one from the set. If you wanted to choose many, then you'd be using a checkbox instead of a radio button. These all work pretty well in the same way, they're just rendered differently. So all I'm going to do is to show you how to use the single selection list box, and then you'll know how to use all of them. The first thing that we do is to identify the name of this list box. That can be useful, for example, when we're wanting to display messages. As you can see here, this is required, and if a selection is not made, then the required message will be displayed. That required message will be linked to this ID. The value is the item selected by the user. As we've seen with text boxes, that value will then be stored in this property of the backing bean. We also need to provide a set of values from which the user can pick. In this example, we've hard-coded the values. Nested within the select one list box element, we've got a number of select item elements, which are value label pairs. The first item has a value of pear with a label the same, and the second one has got a value of apple with a label of apple. Now in this example, I've made the label and the value the same. What will be displayed for the user is the label. What will be stored in the value for the list box, that is in the backing bean's selected fruit property, will be the item value of the item that has been picked. So if we make these different values, then this one is displayed and that one is stored in here. It's all well and good having hard-coded values, but sometimes we want to provide a list of values that has been dynamically generated. For example, we might want to pick a set of permitted values from the database. So we would extract from the database those values that we want in the list and then display them here. But of course, we can't do that if it's hard-coded. So there is another version. The select one list box is exactly the same as it was up here, but instead of having individual select items that are hard-coded, what we've now got is this one select items in the plural, and the value for that comes from this property in the backing bean. Now, of course, because this is being rendered, it's being displayed, the corresponding get method will be called for that property. That get method could very well go and query the database, extract the information, put the values into an array of select item objects, and then return that array. Then the list box will use that array as the list of values to display. This is the first of 3 examples, all revolving around choosing fruit. We're going to make use of the panel grid that we've seen, and also a list box. The first view that the user sees is this one here, where we have a list box with a label of fruit from which the user can pick one value. The user will also type in a quantity and click submit. Clicking submit will then take us to this view, where the selected fruit and the quantity are simply echoed. Clicking the back button will then take us back to index.xhtml. So not a very complicated application, but it will illustrate how we make use of these list boxes. Now, of course, these views have backing beans. We're going to use a single backing bean for both views. Within there, the list of fruit, which is going to be the list that is generated dynamically and is used in the list box. We'll have a selected fruit property, which will store the selection made. So with this selection, selected fruit will equal peaches. And then quantity, of course, will come from there. List of fruit will provide those values. The selected fruit will go into this property and will then again be used over in the second view, and likewise the quantity. So that's the navigation that we provide for the user and the backing bean that supports it. Here's the class diagram for the backing bean. You can see that the list of fruit is an array of select item. You can also see that I've made it static, purely and simply because it's not going to change really, and if it does change, it's going to change for every single instance of this class. So let's take a look at the code for this. This is a backing bean. We want it to be a managed bean. There's its name. It's session scoped, which means that the values from the first request will be preserved for the second request. One of the things I didn't show you was the reset button. Now, reset will restore the view to its original state if the user has made changes since the view was rendered, but before the submit button is clicked. Then clicking the reset will change the view back to its original set of values when it was first rendered for this view. Here's the static array of select items, and you can see that we're setting it up by putting in new select item objects with strings. Those strings will be the values. The get and set methods are exactly as you would expect, and then in the choosefruit.xhtml file, you can see that we've got use of a panel group. This panel group is going to hold this information here so that we get nice alignment on these labels and on the input components. So the first thing that we want inside this panel grid is two columns. We've set up the CSS class for the header and also for the columns. How do I know that I've got a header? Well, I can include this facet with the name equal to header. And it's that that tells the JSF environment that this is to be treated as a header. We'll see how that renders in a few moments when we run the application and then view the source. So choose fruit is the value. There's the header. Then we've got the first element. So that will go into the first column, fruit, that goes in here. Then the second element is going to be this panel group, in which we have got the list box. Usually, you would not need to put a list box inside a panel group because it's only one item, and therefore it would go into the column. But because I want to put the message that could be generated for that list box in the same column as the list box, then I need to group them. If I didn't group them and I still had the message straight after the list box, then that would go into the next column, which would be the first column on the next row. So I'm grouping them, setting them up in just the way that I showed you a few minutes ago. So when we run it, I'm going to submit right now, and you can see that the error messages are grouped with the elements to which they pertain. I'm also going to view the source for a moment. Now you get all kinds of weird and wonderful names here that you wouldn't code normally. This is all generated automatically by the JSF framework. We can see the header, choose fruit, is rendered as a TH element within the table, which is the standard HTML for a table header. The regular elements within the panel grid are rendered as TDs. So if we pick a value and try to pick multiple values by holding down the Shift key, you can see that it doesn't work. This is because this list box is a select one and therefore enforces single selection. And then when I put in a value and submit, that moves us to the next view where the information is simply echoed by extracting it from the backing bean. In this second example, we're going to take the concept a little bit further. So far, all we've displayed in the list box are strings. But of course, fruit could be objects that contain all kinds of information, such as price per kilogram. And that's what we're going to do in this example. So now, instead of displaying strings, we're going to associate objects as the select items for the list box. From that object, we can get other information, such as the price per kilogram, and we're going to display that in the list box as well. And then we're augmenting the second view to display the information, the extra information, and also a calculated piece of information. Given the price per kilogram and the quantity in kilograms, we can now calculate the cost. The backing bean, at first glance, doesn't seem to change. But as I mentioned a few moments ago, this list of fruit although still an array of select item, the value that's inside that select item will not be a string object, it will be a fruit object. And this is what the class diagram now looks like. It's not absolutely strictly correct because I've got an aggregation of select item, and each select item will then have a fruit object. But I didn't want to overcrowd this diagram, so I've just skipped out the select item. But essentially what we've got here then is an array of select item containing fruit objects. For the fruit object, we've got a couple of constructors. We've got some gets and sets for these values here. We've also overridden the equals method, and because we override the equals method, we also need to override the hash code method. You'll also notice that we're using a fruit converter, because now that we're storing fruit objects, when we display those objects in the view, they have to be displayed as strings. So we're going to use a fruit converter to take the fruit object and convert it to a string. But then the selected fruit in the backing bean is now of type fruit. So when the user picks one of the entries in the list, that will be stored in the selected fruit property of the backing bean, but it's going to be stored as a fruit object. As part of that converter, we've got to write a method that will take the string that's displayed in the list and convert it back into a fruit object. We saw these converters in the last learning block with respect to dates when we were using calendar objects. It's exactly the same concept. We have an object and we want to convert it to strings for when we're displaying them in a view and convert them back into objects when we receive those values from the view. And so the converter has the two standard methods, getAsObject, getAsString, and we'll see the code for those in a few moments. Now you can see in this example that I've got different packages, a package for the backing bean, a package for the converter, and a package for the bean. I've done this purely and simply to illustrate that we should be using packages that will help us to categorize our classes. In a simple application like this, it's probably a bit of overkill, but it does illustrate what you could do when you get to the assignment and perhaps have more than one backing bean, more than one Java bean, more than one converter. Let's look at this Java bean to begin with. It has a default constructor, as all Java beans should. It's got get and set methods for its properties, the properties being name and price per kilo. We've also put in another constructor, and here's the equals method that we are overriding from the object class, and the hash code method. It's not my purpose in this module to explain what that is. You can look the information up online if you need it. So there's the bean. Let's look at the converter. This is called fruit converter, so that kind of tells us what it's going to be doing. And when we get as object, we're going to receive a string. That's the new value. And we're going to take that string, which looks like this, the name of the fruit, and in brackets, its price per kilo. And we're going to use the method from the string called split that will allow us to find the location of the open bracket. That tells us where the name ends and where the price begins. From that first bit, we can just trim it so it gets rid of all the spaces in front and behind the name. And then we can take the price part, which at the moment includes a double value and then a /kg. What we're going to do is to trim that, replacing the /kg with an empty string. In other words, we're stripping out the /kg to leave us only with the string that represents a double value. And then we're parsing that into a double and storing it in price per kilo. And then create a new fruit object using the name and the price per kilo that we've now stripped out of the string that was sent to us. That new fruit object is then returned, which is exactly what this method should do. So it's taken a string and converted it to a fruit object, return the fruit object. GetAsString does the reverse of that. It receives an object as the value, and as long as it is not null and it is an instance of fruit, call the toString method, and that becomes the return value for this method. In the backing bean, this is pretty well the same as it was before, except the selected fruit property is now a fruit object reference instead of a string reference. And the select item objects within the array list of fruit are no longer strings but fruit objects. All that being said, From the user's point of view, it all seems to behave as it did before, except that we've now got a bit more information in the list box, which comes as a result of calling the toString method, and the toString method has given us not only the name, but in brackets, the price per kilo. So if we were to pick tangerines, and it's £1.50 per kilo, let's have exactly 1 kilo, then the cost of that is £1.50. Now, how has that been calculated? Well, that's all part of the job of the backing bean, because not only now can we get and set the quantity, but when the fruit has been selected, we can call the get price per kilo method and multiply that by quantity to get the cost. So we've got a get cost method that is called when we are rendering this bit here, cost as string. Cost as string is this method here that is doing the formatting of that price. Now that's one way of doing it, but of course in the last learning block we saw another way in which we could do it, and in the next example I'll show you how that can be done.